All right, so welcome everyone to our Lunch and Learn. I will post these links in the chat again in a few more minutes for those who are joining late. But just to review some administrative announcements, this meeting is being recorded, and we do encourage you to stay muted to minimize interruptions. And this session will not feature a Q&A section, but we will use a Zoom survey at the very end of the session to see if you had any questions related to the SAS Viya transition. And then lastly, all meeting materials will be made available in our CCSQ DNA portal. And with that, let me stop sharing and hand it over to our speaker, and that's Eddie.
Awesome. Thanks, Laura. All right. Do you guys see my Databricks notebook?
Yes, we can see it.
Okay, awesome. Okay, cool. So hi everyone. My name is Eddie Chia. I joined the user services team as staff data scientist about 3 months ago. I have an undergraduate degree in statistics and a graduate degree in machine learning and artificial intelligence. And I have almost 15 years of experience in analytics. I started my career as a SAS programmer and statistician, but over time I transitioned to cloud computing and Databricks. My goal for today's Lunch and Learn is to give you a comprehensive overview of the Spark UI within Databricks and its key features. We'll start with a brief introduction to Spark, discuss the importance of monitoring and debugging for maintaining optimal performance, and then take a closer look at the main tabs in the Spark UI to understand how they can help streamline your workflow and improve efficiency. So what is Apache Spark? Apache Spark is an open source, high performance framework designed for fast, large-scale data processing. By utilizing an in-memory engine, Spark processes data up to 100 times faster than older systems like Hadoop and MapReduce. It supports both batch processing and real-time streaming, making it ideal for a variety of data processing tasks. Spark is highly versatile, offering APIs in Java, Scala, Python, and R, and includes powerful built-in libraries for SQL querying, machine learning, graph analytics, and real-time streaming. This flexibility allows it to address complex data challenges across industries such as healthcare, finance, and manufacturing. Monitoring and debugging are critical to maintaining Spark's performance. Continuous monitoring tracks resource usage and system health, enabling early detection of issues and minimizing downtime. Efficient debugging helps pinpoint bottlenecks, allowing for quick resolution and ensuring optimal operation. Databricks enhances Spark with an intuitive UI for real-time monitoring, troubleshooting, and optimization. This interface offers detailed insights into job performance, resource consumption, and task outcomes, simplifying the management of complex jobs. It tracks CPU, memory, and disk usage to identify inefficiencies and optimize resource allocation. Event timelines and logs further streamline task tracking and error diagnosis. Real-time monitoring empowers users to proactively adjust configurations and improve processing efficiency. Databricks takes Spark's UI a step further by providing a unified interface that integrates with other Databricks tools, enhancing workflows for development, monitoring, and optimization. With performance optimizations, scalability, and collaboration features, Databricks enable deeper insights, accelerating troubleshooting, and facilitating the management of large-scale workloads. All right, so let's take a closer look at the main tabs of the Spark UI. The following code reads data from the electric vehicle population table. It converts the data type of the electric range feature from a string to an integer. It aggregates the data by the make feature and displays 10 records. We'll use the results of processing this code to explore the key features of the Spark UI's main tabs, helping us understand how they can assist in monitoring and optimizing our Spark jobs. So I'll go ahead and click uh, this job. All right, cool. So here's the Spark UI, and we'll just go ahead and go through the main tabs of the interface. So we'll go ahead and start with the Jobs tab. The Jobs tab in the Spark UI within Databricks is a powerful interface for monitoring, analyzing, and optimizing the execution of Spark jobs. This tab features several key sections that offer valuable insights into job performance, resource utilization, task execution, and potential issues. Among these, the event timeline, the DAG visualization, completed stages, and skip stages sections are particularly essential for understanding and improving job execution. All right, so the event timeline. The event timeline section provides a Gantt style graphical representation of the job's execution over time. This visualization enables users to track the sequence, duration, and status of stages and tasks throughout the job lifecycle. It offers a high-level overview of when each stage and task started and finished, with color-coded events to indicate their status. The timeline also displays key events like job submission, stage start and end times, task execution, and retries. Additionally, it tracks resource allocation and deallocation, highlighting inefficiencies such as idle resources or overutilization. This section is invaluable for identifying performance bottlenecks, diagnosing task failures, and optimizing both job performance and resource management. All right, so the DAG visualization, or the directed acyclical graph section, offers a visual representation of the job's execution plan, displaying how stages are interconnected and their dependencies. Each node represents a stage, and arrows indicate the order of execution. This visualization provides clear insight into the job's data flow, parallelism, and task dependencies. By analyzing the DAG, users can identify inefficiencies such as excessive data movement, unnecessary shuffling, or sequential stages that could be parallelized. The DAG helps optimize job execution by suggesting improvements like reordering stages, reducing data shuffling, or enhancing parallelism, ultimately speeding up the job's overall performance. All right, so the completed stages section. This section provides detailed performance metrics for each stage as finished execution. Key information includes the time taken for each stage, the number of tasks involved, and any failures or retries. This section is crucial for analyzing stage performance and identifying inefficient or slow stages. Each stage is broken down into individual tasks, providing insights into such tasks as task duration, memory usage, and shuffle read-write metrics. By examining these details, users can pinpoint tasks that cause delays, consumed excessive resources, or failed and required retries. This information helps refine job execution, optimize resource allocation, and prevent performance bottlenecks in future runs. All right, the skip stages. This tab in the job section of the Sparks UI shows stages that were skipped during a job run. This usually occurs when Spark detects that a stage's output is already cached from a previous run, or when its data dependencies are satisfied by existing data. By skipping redundant stages, Spark optimizes job performance and reduces unnecessary computation. The tab provides valuable insight into which stages were bypassed, helping users analyze performance, optimize jobs, and improve resource efficiency. The event timeline, the DAG visualization, completed stage and skip stage sections in the Jobs tab are powerful tools for monitoring, optimizing, and troubleshooting Spark jobs within Databricks. Together, these sections provide comprehensive visibility into job execution, task level performance, and resource utilization. By leveraging these insights, users can identify inefficiencies, resolve issues, and optimize Spark job performance. All right, stages. Next, the Stages tab in the Spark UI provides a comprehensive view of the stages involved in executing a Spark job. This tab offers valuable insights into both active and completed stages, helping users track job progress, identify bottlenecks, and optimize performance. Key sections within the Stages tab include the fair schedule pools, the active stages, the completed stages, and skip stages, each offering unique perspectives on job execution. First, the fail schedule pools. This section displays how resources are allocated across different job pools within a Spark cluster. It ensures resources are divided fairly among multiple jobs or stages, preventing any single job from monopolizing resources. This section helps users monitor resource distribution, ensuring balanced workload allocation. Each pool may have varying levels of resource allocation, and by examining the usage of these resources, users can ensure optimal scheduling. This section is particularly helpful when running multiple concurrent jobs, enabling users to detect resource contention, imbalances, or inefficiencies that could affect performance. The active stage has actually didn't pop up here, but it often does. I'm going to go ahead and just kind of talk through it at a high level. So the active stage section in the Stages tab of the Spark UI within Databricks provides real-time visibility into stages that are currently executing. It displays key metrics such as task execution time, resource consumption like CPU and memory, and progress towards task completion. This section allows users to monitor live job performance, identify potential bottlenecks, and assess resource utilization. By highlighting active stages, it empowers users to proactively optimize resource allocation, address performance issues, and troubleshoot inefficiencies, ensuring smoother execution and enhanced job performance in Spark applications. Completed stages. This section provides performance data on stages that have finished execution. For each completed stage, that section lists key metrics, including the time taken to complete the stage, the number of tasks involved, and any failures or retries. This data is critical for evaluating the effectiveness of stage execution. Task level details such as task duration, memory usage, and shuffle read-write statistics allow users to dive deeper into stage performance. By analyzing this data, users can identify inefficiencies such as stages that took longer than expected or had high resource consumption. This information is invaluable for fine-tuning job execution, optimizing resource allocation, and preventing similar issues in future jobs. The skip stages section identifies any stages that were skipped. So just like we saw in the previous tab, typically due to Spark optimization, like speculative execution or dependency resolution. A stage might be skipped if its output has already been computed by another task or a stage making it unnecessary. This section helps users understand why certain stages were skipped and whether the behavior aligns with expectations. If stages are skipped unexpectedly, it may indicate issues with the job's logic or configuration, prompting users to investigate further and adjust accordingly. The Stages tab in Spark UI is a vital tool for monitoring and optimizing Spark job execution. The Fair Schedule Pool section ensures balanced resources distribution, while the active stages section provides real-time progress tracking, and the completed stages section offers post-execution insights, and the skipped stages section clarifies any skip stages due to optimizations. Together, these sections empower users to effectively monitor, troubleshoot, and optimize Spark jobs. All right, next is storage. The storage section in Spark UI provides valuable insights into how data is cached, stored, and managed during job execution. It helps users monitor memory and disk usage, optimize caching strategies, and diagnose storage-related performance issues. Some of the key metrics include disk usage. This metric displays the total disk space being used, particularly when data spills over from memory to disk. Monitoring disk usage is essential for identifying potential performance bottlenecks, such as over-reliance on disk storage, which can occur due to insufficient memory and slow down job execution. The metadata cache size. The metadata cache size shows the size of the cache used to store metadata, such as schema information or partitioning details. A large metadata cache can signal that Spark is caching a substantial amount of metadata, which, if not carefully managed, can affect performance by consuming valuable memory. And last, the number of rescheduled scan tasks. This metric counts the number of scan tasks that have been rescheduled due to failures or retries. A high number of rescheduled tasks can suggest resource contention or job instability, leading to delays and additional processing time. The storage section in Spark UI is critical for managing and optimizing data storage and caching. By analyzing key metrics such as disk usage, the metadata cache size, and number of rescheduled scan tasks, users can optimize resource utilization, improve performance, and proactively address potential storage-related issues. All right, next, the environment tab in the Spark UI. This tab provides crucial insights into the runtime environment of a Spark job, including configuration settings, resource usage, and system details. This tab is instrumental for troubleshooting, performance optimization, and understanding the interaction between Spark and the underlying infrastructure. Key sections of the environment tab include runtime information, Spark properties, and resource profiles. So the runtime information section. This section provides essential details about the job's execution environment, such as the Spark version, the Java version, the Hadoop version if applicable, and the Databricks runtime version. It ensures compatibility between the components and confirms that the correct library versions are being used. Spark properties. This section displays the configuration settings for Spark during job execution. These properties influence various aspects of job behavior, including memory allocation, shuffle operations, parallelism, and more. Reviewing these settings enables users to fine-tune Spark's performance based on specific workload requirements. And finally, resource profiles. This section outlines the resource profiles used by the job, detailing how resources like CPU, memory, and executor instances are allocated. It's vital for ensuring efficient resource distribution and helps identify any performance bottlenecks or underutilized resources. The environment tab in Databricks' Spark UI offers a detailed view of the job's runtime environment, configuration settings, and resource usage. By analyzing sections like runtime information, Spark properties, and resource profiles, users can optimize job performance, resolve issues, and ensure the environment is appropriately configured for efficient execution. Next, the executor section in Spark UI. This section provides detailed insights into the performance and resource utilization of executors running in a Spark job. Executors are responsible for executing tasks and storing data in a distributed manner across the cluster. This section is critical for monitoring resource consumption identifying bottlenecks, and troubleshooting performance issues during job execution. Some of the key metrics include storage memory. This metric represents the memory used by each executor to store cache data. Efficient utilization of storage memory is vital for job performance, as excessive memory usage can lead to disk fills, causing slowdowns. Monitoring this metric helps detect memory pressure and inefficiencies in caching strategies. Next, disk used. This metric indicates how much disk space is used by each executor, particularly when data flows from memory to disk. High disk usage may signal that executors are relying too heavily on disk storage due to insufficient memory, which can severely impact performance. And finally, cores. The cores metric shows the number of CPU cores allocated to each executor. More cores allow parallel task execution, which can enhance performance for compute-intensive workloads. Ensuring an adequate number of cores is critical for optimal task processing and resource utilization. The executor section in the Spark UI is essential for tracking and optimizing executive performance by analyzing key metrics such as storage memory, disk used, and cores. Users can identify and resolve performance issues, ensuring efficient resource usage and smoother job execution. And finally, the SQL data frame tab. This tab in Spark UI offers a comprehensive view of SQL queries and data frame operations executed within a Spark job. It serves an essential tool for monitoring SQL query performance, optimizing data frame transformations, and identifying potential bottlenecks. The tab enables users to assess query execution details, diagnose issues, and troubleshoot performance challenges. A key feature within this tab is the completed queries section, which provides crucial metrics and insights into executed SQL or data frame tasks. So the completed query section summarizes all executed SQL queries of data frame operations that have completed, offering detailed performance insights for each. The section includes several key columns that help users analyze and optimize their queries. So first, the ID or the query ID. This is a unique identifier assigned to each executed query. This ID is critical for tracking and referencing specific queries within a job, making it easier to debug, monitor, and cross-reference with logs or other tabs in Spark UI. The description field provides a concise summary of the executed query or data frame operation, including the SQL statement or transformation applied. It allows users to quickly identify the specific query or operation being analyzed, aiding in troubleshooting and performance assessments. And finally, duration. The duration column displays the total time taken for the query or data frame operation to complete. A long duration could suggest inefficiencies such as data shuffling, unoptimized queries, or resource constraints. It can guide users into optimizing queries for better performance. The SQL data frame tab in Databricks Spark UI is a powerful resource for monitoring and optimizing SQL and data frame operations. The completed query section with its key metrics like ID, description, and duration provides valuable insights into query performance and execution timelines. By leveraging this data, users can effectively fine-tune their queries, identify optimization opportunities, and enhance overall job performance. So in summary, Apache Spark is an open source, high-performance framework optimized for large-scale data processing. Its in-memory engine outperforms traditional systems like Hadoop and MapReduce, enabling faster computation. Spark supports both batch processing and real-time streaming and offers APIs in Java, Scala, Python, and R. Its rich ecosystem includes libraries for SQL, machine learning, graph analytics, and streaming, making it a versatile solution for tackling complex data challenges across industries. The Spark UI in Databricks provides an intuitive real-time interface for monitoring, troubleshooting, and optimizing Spark applications. It offers deep insight into job performance, resource usage, and task outcomes, allowing users to swiftly identify and address performance bottlenecks. Key features include event timelines and detailed logs that streamline task tracking and issue resolution. Databricks enhances the Spark UI with powerful tools, including the Jobs tab for visualizing job execution, the Stages tab for monitoring task progress, the Executors tab for tracking executive performance, The SQL dataframe tab optimizes query execution, improving overall job efficiency. Together, these features simplify monitoring, enabling users to maximize performance, scalability, and resource utilization across Spark jobs. Thank you.
Perfect. Thank you, Eddie. All right. Well, that concludes our lunch and learn today. But before you all drop, I will administer the survey that asks you how this lunch and learn went, and also gives you the opportunity to drop any feedback or provide any questions that you would like the DNA team to address at a later point, maybe in a future session. So go ahead and fill that out. And then once you're done, you are more than welcome to drop. Thank you all. And thank you, Eddie.